Okay, so hello and welcome back. So now the next question that we have is question number 2, which is basically you want to find the principal value of the, again, of for example, cos inverse of square root of 3 by 2. The principal value of the principal value of cos inverse of square root of 3 by 2. Right? Now, the cos inverse of, if I say that, if I set cos inverse of square root of 3 by 2, if I set that equal to y, then that means that cos of y is equal to basically square root of 3 by 2, right? Now, I know that basically, so we have the trigonometric ratios table. I know that the cos of 30 degrees is equal to square root of 3 by 2, right? So basically I know that the cos, basically when it comes to 30 degrees, I know that the sine of 30 degrees is equal to 1 by 2, and cos of 30 degrees is equal to square root of 3 by 2, right? Now, what is important again here is that what is important again here is that we said that the range of the cos inverse function goes from 0 to pi, right? So the cos inverse function, we said that it goes from -1, 1, that is the domain of the function. The range of the function is 0 to pi. Right? So you can simply say that basically if you go from 0 to pi, then of course I know that the cos of 30 degrees is equal to the square root of 3 by 2. So cos of y is equal to square root of 3 by 2, which is equal to the cos of, now 30 degrees is equal to pi by 6, right? That means that therefore y is equal to pi by 6, and that is the principal value of, this is the principal value of cos inverse of square root of 3 by 2. To write it a little bit more logically, I can say that let cos inverse of square root of 3 by 2 is equal to y. Then cos y is equal to square root of 3 by 2, which is of course equal to cos of pi by 6. We know that the range of the principal value branch of cos inverse is 0 to pi, which is what I have written over here, and cos of pi by 6 is equal to square root of 3 by 2, and therefore the principal value of the cos inverse of square root of 3 by 2 is equal to pi by 6. Okay, so that was that. And the next question that we have is question number 3. Question number 3 is that we want to find the principal value of the cosecant inverse of 2. We want to find the principal value of cosecant inverse of 2. Now, what you need to do is that if I write basically the cosecant inverse of 2, if I write that as equal to y, then that means that basically the cosecant of y is equal to 2. You need to know what angle you need to have so that the cosecant of that angle is equal to 2. And that angle is basically, so the cosecant over here, as you can see, the cosecant of 30 degrees or pi by 6 is equal to 2, right? I know that the cosecant of pi by 6 is equal to 2. So that is equal to the cosecant of pi by 6, right? Now, what that means is that now the range of the cosecant inverse function, basically is, we said that the cosecant inverse function is a function that goes from r minus the open interval negative 1 comma 1, negative 1 comma 1, and it goes, the range is basically negative pi by 2 comma pi by 2 comma pi by 2, the closed interval minus the set containing 0, right? So that means that the range goes from negative pi by 2 to pi by 2, and 0 is not a part of the range of this function. So negative pi by 2 to pi by 2, and here I have pi by 6, which is of course a part of the range, a part of this range. There is no problem with that. And so you can say that, basically, therefore the principal value of cosecant inverse of 2 is equal to pi by 6. Let me see if my answer is, therefore the principal value of cosecant inverse of 2 is equal to pi by 6. Okay. Now question number 4. We have tan inverse of negative square root of 3. So we want to find the principal value of tan inverse of negative square root of 3. So if I write the tan inverse of negative square root of 3 is equal to y, that means that tan of y is equal to negative square root of 3, right? And this tan of y is equal to negative square root of 3. Now you need to somehow find some angle. Now I know that tan of negative x is equal to negative tan x, right? Negative tan x. So what that means is that if I take a look at these the tan function over here, the square root of 3 is over here related to the angle 60 degrees or pi by 3. That means that tan of pi by 3 is equal to square root of 3. So I know that tan of pi by 3 is equal to square root of 3, right? So this means that this is equal to negative tan of pi by 3, right? And since since we have negative tan of x is equal to tan of negative x, I can write it as tan of negative pi by 3. Which means that now this gives tan of y. Tan of y is equal to tan of negative pi by 3. Now before writing y is equal to negative pi by 3, I need to check the domain and range of this function. So the domain and range of this function is basically the tan inverse function. We know that the tan inverse function goes from r to negative pi by 2 to pi by 2, the open interval, right? And pi by 3 is 60 degrees, right? So 60 degrees is, well, it's somewhere before pi by 2, so you have no problem with, actually it's negative pi by 3, so it's down in the unit circle, so you have no problem with that. It's a part of this domain, it's part of this range, which means that you can write, therefore, so I can write over here, what I can write is that y is equal to, basically, y is equal to negative pi by 3, and therefore the principal value of tan inverse of negative square root of 3 is equal to negative pi by 3. And that is question number 4. Now, question number 5. Question number 5, we want to find the principal value of, cos inverse of negative 1 by 2. Cos inverse of negative 1 by 2. Okay, so now if I say that for example, let cos inverse of negative 1 by 2 be equal to y. Now if that is the case, then that means that basically cos of y is equal to negative 1 by 2. Cos of y is equal to negative 1 by 2. Which means that now basically what angle do you have for which the cos basically is equal to 1 by 2? That's 60 degrees. When you basically 60 degrees is the same thing as pi by 3, and the sine of, you see there is a relationship between 30 degrees and 60 degrees, and you need to, if you know this relationship, most of the time you can remember these angles. You see, basically when it comes to 30 degrees or pi by 6 radians, sine of basically pi by 6 is equal to 1 by 2, and cos of pi by 6 is equal to square root of 3 by 2. Okay, so this is about, and there is also, these are also called complementary angles or something like that, and there is a relationship when it comes to the trigonometric ratios of complementary angles. I don't exactly remember that. If we get to that, I will let you know, of course. But it basically comes, it basically depends, it's based on the fact that basically when you have suppose that you have a triangle, a right triangle, and in this right triangle, let's assume that you have a 30-degree angle. So you have this triangle over here, right? Now, if you have this triangle, what happens is that you have A, B, and C, and let's say that this angle is 30, this angle is 90, and so of course automatically this angle becomes 60 degrees, right? Now in this triangle, what happens is that there is a certain relationship between the sides well, I will talk about this in detail. I will basically prepare what is related to these complementary and supplementary angles when it comes to trigonometric ratios, and I will talk about that properly. This way we are not going to get anywhere with that. But long story short, when you have basically 30 degrees, sine of pi by 6 or sine of 30 degrees is equal to 1 by 2. Cos of the same angle is equal to square root of 3 by 2, right? Now, when it comes to 60 degrees, what happens is that the sine of this angle, the sine of 60 degrees, is the same thing as the cos of the other angle, which is square root of 3 by 2. Okay? And the cos of this angle, the cos of 60 degrees, is the same thing as the sine of this angle, which is equal to 1 by 2. Now, here you need to pay attention to the fact that these angles, if I call this, for example, alpha, and if I call this, for example, beta, alpha plus beta is equal to 90 degrees. And 90 degrees, when two angles are basically make a 90 degrees, those two angles are called, there are two types of angles as far as basically these two terms are concerned. There is complementary and supplementary angles. Okay, so you can see that supplementary angles are two angles whose sum is 180 degrees, while complementary angles are two angles whose sum is 90 degrees. Supplementary and complementary angles do not have to be adjacent or sharing the vertex and side or next to, but they can be. Now this is of course no good explanation, I mean the last part at least. But when two angles, the sum of two angles is 180 degrees, you call them supplementary. When the sum of those two angles is 90 degrees, you call them complementary. Okay? Which means that the angles are complementary. Are complementary angles. And this thing happens, this sort of phenomenon happens, meaning that starting with 30 degrees, sine of 30 degrees is equal to 1 by 2, cos of 30 degrees is equal to square root of 3 by 2, and then what happens is that basically the sine of 60 degrees is equal to the cos of the 30 degree angle, which is equal to square root of 3 by 2, and the cos of 60 degrees is equal to the sine of 30 degree angle, which is equal to 1 by 2, right? And we can see the same thing over here as well, which is, as you can see, the sine of 30 degrees is equal to the cos of 60 degrees, 1 by 2, 1 by 2. And the cos and the sine of 60 degrees is equal to the cos of 30 degrees, square root of 3 by 2, square root of 3 by 2, right? And you can see the same thing over here as well. For example, as you can see, the tan of 30 degrees, square root of 3 by 3, is equal to the cot of 60 degrees. And the tan of 60 degrees is equal to the cot of 30 degrees, right? Square root of 3, square root of 3. And you can see that the secant of 30 degrees is equal to the cosecant of 60 degrees. And also the secant of 60 degrees is equal to the cosecant of 30 degrees. So this kind of thing happens between sine and cos, tan and cot, secant and cosecant. Now there was a name for these trigonometric ratios, but I do not remember much about that right now. We will talk about that properly later, okay? Now, so what that means is that basically basically now we said that the cos of y is equal to negative 1 by 2, right? The cos of y is equal to negative 1 by 2. Now, what angle do you need so that the cos of that angle is equal to not negative 1 by 2, but 1 by 2? Well, I know that when it comes to 60 degrees, cos of 60 degrees or cos of pi by 3 is equal to 1 by 2. So I can write this as the negative cos of pi by 3, right? Negative cos of pi by 3. Now, additionally, I know that the cos of negative x is equal to cos of x. Is equal to cos of x, which means that if I have a cos of negative cos of x is equal to, which means that I can write this as cos of negative pi by 3, right? So when cos of x is equal to cos of negative x, what that means is that when I have when I have basically, I'm sorry, there is a mistake here. Which means that when I have the cos of pi by 3, I can write it as the cos of okay, so I thought about this for a few seconds or a few moments, and I think there is no way to solve this problem this way. So what we can do is that we can basically we can actually use the unit circle. So if I have the unit circle here, and suppose that I have the angle pi by 3. So the angle pi by 3 is basically pi by 3 is equal to 60 degrees, right? So that's 15, 30, 45, and 60. That is pi by 3. Now the cos of, I know that the cos of 60 degrees is equal to 1 by 2. This length over here is equal to 1 by 2. Now what is the, basically what is the angle that you can, if I, what is the angle, what is the angle that has a, that this is a positive value, of course. Now what is some other angle that I can find in this circle that has the opposite, algebraic opposite of 1/2, right? So of course I could come over here and draw this angle, and then this angle would have the exact same cos value. Or I could probably come over here and draw this angle, and this would have the exact same distance from the center of the coordinate system, but it's a negative value. Moreover, I could draw this angle, right, and it would have the exact same cos value, negative, of course, right? So that means that the angles that I can have are, first of all, one of them is this one, which is basically 90 plus 30 is equal to 120 degrees, and there is also this angle, which is basically this is 30 degrees, so this is 60 degrees. 180 plus 60 is equal to 240 degrees, right? 240 degrees. Now, so I need to pick one of these two angles, provided that the angle is actually in the range of the cos inverse function. So in the range of the cos inverse function, so we said that the cos inverse function is a function that goes from -1, 1, the closed interval -1, 1, and that goes to 0, pi. So the only way that I can use this function, I can go from 0 to pi here, from here all the way up to here, but I cannot go down here, which means that I have to take this angle, which is 120 degrees. Now 120 degrees is the same thing as what? It's the same thing as, well, you have 30 degrees here, so you have 3 times 30 degrees here, which is 90 degrees, right? Plus 1 times 30 degrees is equal to 4 times 30 degrees. 30 degrees would be pi by 6. So you have 4 times pi by 6, which is 2 times pi by 3, right? Which means that basically 120 degrees in radians would be 2 pi by 3. Now this is a way that you can use in order to convert, instead of basically using the formula that we talked about earlier. What you can do is that, let me show you the formula first. We said that if you wanted to convert from radian to degrees, or from degrees to radians back and forth, suppose that you have this angle over here, which is basically suppose that you have this angle over here, which is 120 degrees. Now I know that basically 1 degree, based on the formulas that we talked about, I know that 1 degree is the same thing as pi divided by 180, pi divided by 180 in radians, right? So if 1 degree is equal to so many radians, 120 degrees would be 120 times so many radians. So that's the same thing as 120 times pi divided by 180 in radians. And so I'll get 18, 12 divided by 6, I'll get 2 divided by 6, I'll get 3. And that's the same thing as 2 pi by 3 radians, right? Which is the same thing I've written over here. Now, another way that you can use in order to convert the same angle is that you need to, for example, I know that my angle is 120 degrees. So 120 degrees means that means that I have basically I have a 30-degree angle here, another 30-degree angle here, another 30-degree angle here. You see I have a 30-degree angle here. I have another 30-degree angle here, and I have another 30-degree angle here. There are 3 30-degree angles in each quadrant, which makes each quadrant 90 degrees. So I have 1, 2, 3, and 4 30-degree angles. So each 30-degree angle in radian is pi by 6 radians, right? So that is 1 pi by 6, 2 pi by 6, 3 pi by 6, and 4 pi by 6. So over here I have written 4 pi by 6. And so of course I can simplify. I can divide by 2, I'll get 2, divide by 2, I'll get 3. That's equal to 2 pi by 3 in radians, right? Okay, so what this whole thing means is that basically we said that cos of y is equal to negative 1 by 2, which is equal to negative cos of pi by 3. And I can actually write this as the cos of, the cos of, basically, there is no negative there, of course. I can write it as the cos of basically 2 pi by 3, right? I can write it as the cos of 2 pi by 3. And so what that means is that basically then y is equal to 2 pi by 3. And therefore the principal value of, the principal value of cos inverse of negative 1 by 2 is equal to 2 pi by 3, right? You need to just simply put a couple of things together, get yourself some argument, some logical argument, and it's, I mean, not always is it going to be exactly straightforward. Sometimes you have to use the unit circle and so on and so forth. And there are all of these formulas that you can use. For example, in the solutions, I can see here that they have written, for example, in this step, which was basically, for example, this step right here. In the beginning, I'd written this as negative cos of basically cos of pi by 3, right? Negative cos of pi by 3, right? Now, there is actually a formula for this. Instead of using the unit circle, I can use the formula. And the formula is that the cos of pi minus pi by 3, pi minus pi by 3, or pi minus theta, I'll write that later, is actually equal to negative cos of pi by 3. In other words, I can say that the cos of pi minus theta is going to be equal to negative cos of basically theta. And of course you can find this formula this way. For example, let me show you one way that, I mean, one of the formulas. Of course, we have talked about this in another video as well. But we said that basically we introduced 4 formulas for these angles. We said that cos of x minus y is equal to cos x cos y plus sin x sin y, right? So now if I set x is equal to pi and y is equal to theta, then I will have cos of basically pi minus theta. Pi minus theta is equal to cos pi cos theta plus sin pi sin theta. Now, of course, you know that cos pi is equal to -1, right? Cos pi is equal to -1. So that's -1 times cos of theta plus sine pi is equal to 0. So this whole thing becomes 0. This is plus 0. So that's negative cos theta. And therefore, cos of pi minus theta is equal to negative cos theta. That's basically a formula that you can use in such situations. So you have to get yourself a bunch of these formulas, meaning that you have to play with all of these 4 formulas that we talked about: cos of x plus y, cos of x minus y, cos of sine of x plus y, sine of x minus y. And then you have to basically go into the unit circle. You have to start from pi by 2, for example. Then you can create all of these formulas. For example, what is, for example, sine of pi by 2, for example, plus theta? What is, for example, cos of pi by 2, for example, plus theta, right? And so on and so forth. Then you can get to pi, and then you can do the same thing with pi. For example, what is the sine of pi minus theta? What is the cos of pi minus theta? What is the sine of, for example, pi plus theta? What is the sine of pi, for example, minus theta? Then you can do the same thing with 3 pi by 2. You can do the same thing with 2 pi, and that way you will have all the possible formulas that you could ever need. But it's not easy to remember them. And well, when I was in college, we used to write these like 1,000 times to remember them, and eventually after 6 months or so I had managed to memorize them. But it's always easy to use the unit circle and find the angle that you're looking for. So they're really not that important. But of course, it's nice to know them, and it's nice to have them as a part of your working memory if that's possible for you. I don't know, it just depends on you, your personal preferences. Okay, so that was basically question number 5. Okay, so the next question that we have is tan inverse of -1. You want to find the principal value of tan inverse. So we want to find the principal value of tan inverse of -1, right? Now, again, you need to, if I say that basically the tan inverse of -1 is equal to y, that means that basically tan of y as an angle is equal to -1. I do not, let's take a look at the table that we have. You see that tan of 45 degrees is equal to 1, and so tan of 45 degrees is equal to 1. So I know that tan of 45 degrees, which is equal to tan of pi by 4, is equal to 1. And we also know that the tan of the negative x is equal to negative tan of x, right? So I can write this as the negative tan of basically pi by 4. So because tan of pi by 4 is equal to 1, so that -1 is negative tan of pi by 4. Now, negative tan of pi by 4 is equal to tan of negative pi by 4, based on this formula. But before writing y as negative pi by 4, so that means that basically tan of y is equal to tan of negative pi by 4, which means that now let's take a look at the domain and all of the business related to the tan inverse function. Basically about the tan inverse function, we have the domain is R and the range is negative pi by 2 to pi by 2, which means that basically negative pi by 4 is actually in the range of the function, so we have no problem there, and therefore you can write y is equal to negative pi by 4, and therefore the principal value of basically tan inverse of negative 1 is equal to negative pi by 4. Okay, that's question number that was question number 6. Question number 7, we have basically the secant inverse of 2. We want to find the principal value of the secant inverse of 2 over square root of 3. 2 over square root of 3, right? So if I say that, if I basically let secant inverse of 2 over square root of 3 is equal to y, for example, that means that the secant of y is equal to 2 over square root of 3, right? And what that means is that basically now let's take a look at the secant functions. Let's see what sort of values we have for the secant. There might be some mistake over here. Secant of pi by 6 is equal to okay, so 2 square root of 3. Well, they have written this basically in so 2 over square root of 3, you can write it as 2 square root of 3 over 2 square root of 3 times square root of 3, which is equal to 2 square root of 3 over 3, which means that 2 over square root of 3 is the same thing as 2 square root of 3 over 3, right? And basically the table that we had here, basically the secant of pi by 6 is equal to 2 square root of 3 thirds, which is basically the same thing as 2 over square root of 3, right? So that is secant of pi by 6. So this is equal to secant of pi by 6, which is basically 30 degrees, is the same thing as 2 square root of 3 thirds, which is equal to 2 over square root of 3, right? Now, what that means is that, so that means that this is simply equal to the secant of pi by 6, right? Now, what the only thing that we need to be careful about is the domain and range, and the secant inverse function. We said that the secant inverse function is a function from r minus the open interval of -1, 1 to basically 0, pi, the closed interval of 0, pi minus pi by 2, right? So 0 to pi and pi by 6. So this is in the range of the function. We have no problem. So you can say that basically y is equal to pi by 6, and therefore the principal value of value of basically secant inverse of 2 over square root of 3 is equal to pi by 6, right? Is equal to pi by 6. That was question number 7. Now question number 8, we have cot inverse of square root of 3. Cot inverse of square root of 3. Now if I let cot inverse of square root of 3 be equal to y, for example, then what happens is that implies that cot of y is equal to square root of 3. Now the cot function is basically, you can see that the cot of pi by 6 is equal to square root of 3. Cot of 30 degrees is equal to square root of 3. I know that cot of pi by 6 is equal to square root of 3. So this is the same thing as cot of pi by 6. And so the domain of the range of the cot inverse function, is a function that goes from r to 0 to pi, with the open interval of 0 to pi. And pi by 6 is actually in this range. So I can say that basically y is equal to pi by 6. And therefore, the principal value of basically cot inverse of square root of 3 is equal to pi by 6. That was question number 8. Question number 9, we have the cos inverse of -1 over square root of 2. Question number 9, we have the cos inverse of -1 over square root of 2. Now if I let basically the cos inverse of -1 over square root of 2 which is ultimately equal to square root of 2 over 2, because now ignoring the sign for now, 1 over square root of 2 is equal to square root of 2 times 1 over square root of 2 times square root of 2 gives you square root of 2 over 2. And I'm converting these numbers because in the table I have converted all of the numbers. I have rationalized all of my fractions. So then I can say that this is equal to cos inverse of negative square root of 2 over 2, right? And if that is the case, and I set this equal to y, that means that basically cos inverse of, so if the cos inverse of negative square root of 2 over 2 is equal to y, that means that cos of y is equal to negative square root of 2 over 2. Now, the cos of what angle is square root of 2 over 2? That is pi by 4, 45 degrees, right? you see over here the cos of pi by 4 is equal to square root of 2 over 2. I know that the cos of pi by 4, which is 45 degrees, is equal to square root of 2 over 2. Now this is the same thing as negative cos of basically pi by 4. Okay. Now I also know that the cos of negative x is equal to cos x. But I don't have negative cos x over here, so I cannot use this formula. I have to use the unit circle in order to find out what is basically, what angle basically gives me the negative of cos of pi by 4, right? So if I draw a unit circle over here, I can draw a unit circle over here and can come over here and border and okay. So then the angle pi by 4 is this angle over here. This is pi by 4. Now the cos of pi by 4 is this length over here. This is basically, this is the cos of pi by 4, this length. This is the cos of pi by 4, which is a positive value, and it is square root of 2 over 2. It is square root of 2 over 2, which is something about 0.7 or so, right? Now negative cos of y is equal to negative of cos of pi by 4. Now negative of cos of pi by 4, if I draw some angle over here, something like this, you can see that it's going to have the exact same cos value. If I draw some angle over here, it's going to have basically the length is going to be the same, but it's negative. Also, if I draw some angle here, it's going to have the exact same cos value but negative. Now this angle is 1, 2, 3 pi by 4. 3 pi by 4, so this is 4 pi by 4, then this is 5 pi by 4. Meaning that this is, well, 90 plus 45 is equal to 135 degrees. And then 180 plus 45 is equal to 225 degrees, right? 225 degrees. Now, what that means is that either this angle or this angle is going to have the cos of that angle is going to be negative of the cos of pi by 4. Now, the cos inverse function, the range of that is basically, the cos inverse function is a function that goes from negative 1 comma 1 and goes to 0 comma pi. That is, the range of the function is 0 to pi, meaning that you can start from here and go all the way up to here only, not this angle. So the angle that you're looking for is actually 3 pi by 4. So that is equal to the cos of 3 pi by 4. 3 pi by 4, right? And since this angle is of course in the range of the function, you can say that basically y is equal to 3 pi by 4. And therefore the principal value of basically cos inverse of negative 1 over square root of 2 is equal to 3 pi by 4, which is the same thing as 135 degrees. Okay, so that was question number 9. Now I'm going to end this video here, and we will continue with these in the next video. Thank you.